All right, so 10.1 is all about triangle properties. Okay, so first thing we're going to do is to figure out how many different ways we can classify them. Okay, so we can classify triangles in two ways. So the first one is the lengths of their sides. So here's a triangle. We can classify them by the lengths of their sides, or by the degree measures of their angles. So the angles are the inside numbers, right? And one other thing that's important about triangles is that they all add up to be 180 degrees. Okay, so let's talk about classifying them by their sides. There are ways, three ways to classify by sides. The first one is called scalene. So a scalene triangle. There's also an isosceles triangle. And lastly, an equilateral triangle. Okay, so scalene triangles have zero congruent sides. Have zero. So that means all of their lengths are different numbers. Isosceles triangles have two congruent sides. So that means two of their sides are the same length. And that's normally marked with little dashes. And then equilateral is when all three sides are congruent. So as we said, the three little dashes show us that those three sides are all the same. Okay. And then let's talk about how you classify them based on their angles. So there are four ways to classify them that way. Four ways. Oh. Four ways to classify them. Oh, trying to erase them, it's not working. Four ways. The first one is by is an acute angle. So remember, an acute angle is less than 90 degrees. There's an obtuse angle, which is more than 90 degrees. There's a right angle, which is exactly 90 degrees. So that kind of looks like this, and it's normally marked with a little angle. Obtuse is really wide, is a really wide angle, and acute is a really small angle. And then the last one is equiangular, which means all angles are the same, or in this case, 60 degrees. Okay? So let's talk about the first type of triangle. So acute triangles have three acute angles. So they're all less than 90 degrees. Because remember, 90 would come out like this, or like this, or like this. So it'd be exactly square. Then we have obtuse triangles. Obtuse triangles have one obtuse angle, which means one angle is really, really large instead of the 90 degrees that it should be. Okay. Right triangles have exactly one right angle. So this corner here is exactly a right angle. And then last one, equiangular, G-U-L-A. Equiangular triangles have three congruent angles. So all of the degrees are 60 degrees. Okay, so let's practice classifying these. So let's go to the next page. So classify the triangle by its side and by its angle. Okay, so looking at these, looking at this first one, all of these are less than 90 degrees, right? So if it's less than 90 degrees, then it's an acute, because they're all less than 90 degrees. And then it's kind of hard to tell, but these two are the same length. So these two are the same length. So that tells me that it's an isosceles. So it's an acute isosceles. Let's go to the next one. So we have to look at our angles. This is acute, 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 but this is obtuse. So it means that this is an obtuse triangle. And not all of these are the same, right? This one's a little longer than this one, and then this one's the longest. So it's going to be a scalene because not all of them are the same. Very last one. This is an acute angle, acute angle. This is a right angle. So it's a right triangle. And then again, looking at these sides, they're all different lengths. So it's going to be a scalene. Okay. So now let's talk about a theorem that we have. So triangle inequality theorem helps us determine if given sides, if it's a triangle. So in order to form a triangle, the sum of the smaller two sides, two side lengths must be greater than the third side length. So what that means is you have to take the smallest two sides, add them up, and they should be greater than the third. So the first two should be greater than the third. If they are, then it is a triangle. If it's not, then it's not a triangle. So let's look at looking at example 2. So we have to add up the smaller two sides. So the smaller two sides are 5 and 8, and we're saying that's greater than the longest side, which is 10. So 5 plus 8 is 13. Is 13 greater than 10? Yes. So these do form a triangle. Okay, let's look at the next one. Again, we want to add up the two smallest sides. So 9 plus 12. And we want those to be greater than the longest side, which is 16. 9 plus 12 is 21. Is 21 greater than 16? Yes, so they do form a triangle. All right. We're going to do the last one next. Two smallest sides are 20 plus 14. We're saying that has to be greater than 33. So 20 plus 14 is 34. And 34 is greater than 33. So then yes, these do form a triangle. Okay? So sometimes you might be given two sides and have to figure out the third side, right? So we're going to assume the third side is the longest. So we want to add up the two smallest. So we'll do 13 plus 8, and saying that has to be greater than the third side. So 13 plus 8 is 21. So 21 has to be greater than the third side. So that means we want to pick a number that's smaller than 21. So in this case, it'll be 20. Okay, because we want the third side to be smaller than the other two. Okay, so I want you to try the last one on your own, and we'll check that in class next time we see each other.